Welcome to our third event on Azure Stack HCI 21H2, focusing on stretch clustering with high availability and disaster recovery. We'll be covering off many of the new capabilities in this session, as well as design best practices, recommended hardware and network requirements, and the overall operational benefits these will bring, while also delving into the technical aspects. My name is Terry Story, Chief Cloud Officer at Acuutech. I would also like to introduce my co-presenter for today, Tony Luchford, Head of Technical Sales at Acuutech. Before we start though, I'd like to kind of give a quick update in terms of Azure Stack HCI 21H2. As some will know, this has just reached general availability for over-the-air updates on the 19th of October. This means existing Azure Stack HCI 20H2 customers can in-place upgrade to 21H2. But before doing so, please check with your OEM when they will provide support for your hardware configuration and plan accordingly. Before we dive into the main session, I'd also like to remind everyone of our previous Azure Stack HCI session delivered on the 30th of July. We discussed many of the new capabilities in 21H2 as a whole and the operational improvements these bring to reduce the time to complete lifecycle management activities, driving a more automatic approach to standardized maintenance procedures. Please review this video to provide further context on the new features and capabilities of how Azure Stack HCI 21H2 and Azure Arc can help in the journey to hybrid cloud, especially if Azure is your direction. I would also like to offer an opportunity to 10 demos after this event for both stretch clustering and GPU high availability, as there's quite a lot of ground to cover in these areas. Please send requests to the following email address that you'll see in the slide in front of you. This session today builds on this further and delves deeper into the technologies that enable all of this, whilst also outlining the improvements in high availability, disaster recovery with stretch clustering, and further improvements this brings to the overall operational posture. So what is high availability? In its simplest form, this provides a known level of performance with longer service uptime. High availability solutions are more durable, provide for longer uptime with less chance of impact to service if multiple failures occur due to increased fault domains across servers and sites. Now with Azure Stack HCI stretch clusters, you can fail over resources locally and to a secondary site, increasing the fault domain, for example, from 2 to 4. This means you would need to have more than 4 failures before a service outage would occur. If you compare this to a standard HCI cluster, typically after 2 failures, an outage would occur. So a big difference there. Now, a quick side note. This assumes we are leveraging nested mirror and nested map for storage replica logs and data volume configurations as a best practice for a 4-node stretcher, or a 3-way mirror with an 8-node stretch or larger. Now, this kind of drives us to think about leveraging stretch clusters for high availability as a norm within a rack or adjacent rack in the same data center with virtual sites. Yes, you can have virtual sites and physical sites. And typically virtual sites can be leveraged for, installing stretch clustering local within a data center and really improving that high availability, increasing the fault domains. But typically most people think about stretch clustering as physical locations and providing for disaster recovery. Now, if you think about, disaster recovery, this essentially provides a means to access IT infrastructure after a natural disaster occurs in one location. And we've agreed SLAs to bring these infrastructure services back up in another location. With Azure Stack HCI, this can be configured to automatically fail over to a second location and bring up all services online without any operational intervention to shorten the time to meet SLAs. And that's a key thing here. Automatic means you get less fat fingers, less things to go wrong. It's complete automatic process. And this is kind of usually required for typically known, SLAs and durations for recovery point objective and recovery time objective, because you're minimizing the time to bring the service back online. And all of this can be configured on a per volume basis. And as we all know, the groups of virtual machines are tied to particular volumes. So you can actually configure those recovery point objectives and recovery time objectives on a per volume basis. Now, another area of interest is also disaster avoidance. So if you imagine that, you can initiate a manual planned failover to another location to avoid a disaster, such as a flood or a hurricane. Now, at Acuutech, we believe disaster recovery, disaster avoidance should be inherent in every design and deployment of Azure Stack HCI, whether it's in place at the outset or can be simply incorporated and extended in the future, which is entirely possible with Azure Stack HCI, as everything is software defined. And we'll go through in a bit more detail later on in this presentation. Another important note is that we recommend only leveraging tested, validated configurations that are specifically designed for Azure Stack HCI stretch clusters from Acuutech or from your favorite OEM, rather than try and build your own, because there are lots of moving parts to this in terms of getting the right storage, getting the right networking, and sizing everything to get the right outcome to meet your SLAs. And we'll go into a bit more detail around a lot of those areas. Now, we think about the types of configurations that you can have in a stretch cluster. Let's start with active-active. Now, active-active enables data volumes and virtual machines to run in both sites, and it's important to size the memory, processor, and storage to accommodate all workloads failing over to a single site in case of a planned or unplanned failure. Now, we would typically think about doubling the memory, processor, and storage to accommodate running all workloads in a single site for active-active configurations in case of a failure of a site occurs. Now, especially if all workloads need to keep running in the remaining site, you can of course configure each volume and its workloads to automatically fail over, or to configure the manual for a manual failure level. Again, choices. Now, active-active clusters are not typically leveraged for long distance between locations. These are great for short distance, campus, and metro networks with low latency and high bandwidth networks to meet the increased SLAs of this type of solution. Of course, there is not one size that fits all, and it's a consultative exercise to design the solution to meet your performance and SLA requirements. Some further additional guidance on stretch clustering. All cluster nodes in a stretch cluster needs to be symmetrical. They need to be the same in terms of storage, processor, memory, and networking. The cluster node count across a stretch cluster also needs to be even. For example, a 2+2, a 3+3, a 4+4, and a 5+4, all the way up to an 8+8, but never a 2+3 or a 4+5 or a 1+2. The outcome needs to be an even set of numbers across the two sites for a stretch cluster. Now, stretch clusters themselves support up to between 4 and 16 node configurations. At the small end, a 4-node stretch cluster requiring 2 nodes per site, and at the high end, 8 nodes per cluster per site, giving you 16 nodes. Let's move into active-passive. For active-passive, this enables data volumes and virtual machines to run in one site only, and is also important to size the memory, process, and storage to accommodate failover of required workloads to the second site. Now, we would typically think about mirroring the primary site memory, process, and storage to accommodate failover of all workloads to the second site. We would not require to double the memory, process, and storage, as in this case, compared to active-active configuration, unless there was a planned transition from an active-active configuration over time, which can occur on a per volume basis. So again, thinking about the configuration of stretch clustering today and your plans for the future, and include that in the configuration of all the hardware. And also in an active-passive configuration, the recommendation is that you would set up configure this as a primary site. You'd pick one site and you set that up as the default preferred site. So when you bring the cluster up, that site is always there running the volumes and running all the VMs in that site. And the second site is also is always just sitting there in case of a failure. And let's move into the stretch clustering and storage replica section. Now, with storage replica, this is supported for active-active and active-passive, obviously, and you can set up configurations for both to support synchronous and asynchronous replication at the volume level. So we can design to provide the required recovery point objective and recovery time objective for each specific volume and associated virtual machine workloads. As a rule of thumb, for synchronous replication, this typically requires short distance, campus or metro, lower latency WAN links, as I mentioned earlier, but also to be less than 5 millisecond return time for synchronous, and ideally 10 gig bandwidth to handle the right churn of workloads. So we ensure in your testing that the bandwidth in place can keep up with the right churn. For synchronous, this will be seen at the workload in terms of usability and performance. So essentially, as you're committing storage replica writes across to the second site, it's only when it's fully committed through the system do you get that transaction completed at the virtual machine level. And if your bandwidth and latency your bandwidth is too low and your latency is too high, you'll see that impact at the workload level. Now, for asynchronous replication, this is different. This supports longer distances and is less concerned about latency, as this does not impact the VM workloads, but does require adequate bandwidth to accommodate the right churn of active workloads to keep up with the recovery point objective, whether that be 30 seconds or higher. So what does that mean? It means that, yes, you can have higher latency, you can have lower bandwidth, and the virtual machine will run. There'll be no impact there, irrelevant of those two things, but your recovery point objective will be longer than the time that you want. So you need to make sure that your bandwidth is adequate to deal with the right churn of the workloads. Now, there's an area that you can go and verify all this. So in your testing phase for asynchronous replication, and you're testing all your workloads, and recommend that using test SR topology and this disk SPD to complete all these testing before you go live. You really want to look for event logs of 1239, which indicates that your RPO is higher than what is configured due to network bandwidth constraints. Or if you see an event ID 1240, which indicates your bandwidth is sufficient for your write churn. All of this needs to be concluded with all your testing before you go live, to inform you that you are meeting your SLAs with your current network configuration. Additionally, if synchronous replication is chosen at the volume level, then automatic failover will occur. If asynchronous replication is chosen, then we'll require manual failover of the data volume and associated virtual machine workloads. Please keep this in mind when you're designing your solution. Now, if you don't get this right first time, you can go and change from async to sync and vice versa. So there's not a problem. Now, when we think about requirements with stretch clusters, I've kind of highlighted some of the key areas here. There are some baseline requirements for Azure Stack HCI stretch clustering in terms of Active Directory. This is required to support live migration between the sites, storage replica, and cluster-aware updating, while also providing time synchronization for the whole solution. Active sites and subnets can also be leveraged by stretch clusters with a new capability called AutoSite. This pre-populates the cluster fault domain to site when the cluster is first created to ensure servers reside in the right site before we deploy Spaces Direct. This ensures the new cluster and storage pools are deployed based on the actual sites and location that you desire. So we can automate and simplify the deployment of the cluster and its associated storage pools and the associated virtual disks around that depend on them. Active Directory also supports Active Directory integrated DNS. Now, I like this because it allows me to provide multi-site writable versions of DNS for high availability. You can also include DHCP in each site if there is no layer 2 stretch VLANs for the VM workload IP address network to leverage. Now, that's a bit of a mouthful. I'm going to go into that in a bit more detail. So we can support continuations of service when failure of the VMs between sites. Now, I'll give you an example here. If there is no layer 2 stretched VLAN in place for the virtual machine IP address space, sometimes called the IP application space, then when a VM moves to the secondary site, it will not have a valid IP address to provide continual service. What we can do then is provide a DHCP service in each site. When the VM live migrates or is restarted on the secondary site, will automatically request a new IP address. We then need to configure DHCP to reduce the IP address lease time and reduce the DNS record of time to live to ensure clients can expire those cached DNS records and resolve to this new IP address with the same DNS name to meet SLAs. This again is a configuration and testing exercise for each of your critical application workloads. And last but not least, a core witness that reside in cloud as a blob store or a third site to ensure we can provide a vote for maximum fault domains and resiliency if a failure does occur. Now let's kind of jump in and change gears a little bit and think about new features and capabilities within 21H2 and more specifically how they benefit a stretch cluster. Now, FIM provisioning of a volume is a new capability in 21H2. When combined with stretch clustering, will reduce the time to complete storage replica initial sync from literally hours to seconds, as the sum of replication is scoped to the metadata and VM workloads on the volume and not the size of the volume and its white space when compared with a fixed provision volume that existed in the past. This is an absolute game changer. So what does this mean in practical terms? Well, if I create a FIM provision volume, only the metadata takes up space in the storage pool. For argument's sake, let's say this is 10% compared to 100% of space taken up with a fixed volume. The initial sync of a FIM volume for storage replication only needs to sync these bits and not the whole volume. This is the massive difference. There's some good areas there in terms of FIM provision. So what are the kind of the limits with FIM provisioning? If you storage migrate a VM or delete a file from the FIM provision volume, then this space would normally be reclaimed through RSR map within 15-20 minutes in a standard 21H2 HCI cluster. With stretch clustering and storage replica, this currently does not get reclaimed. The volumes will continue to grow. So this is not a supported capability today within stretch clustering. Furthermore, at this time, you cannot over-provision a FIM volume beyond the physical storage available in Windows Admin Center, unless the only way you can do this is if you create the volume through PowerShell. And also, you cannot convert a fixed volume to a FIM volume or FIM volume to a fixed volume today either. Let's move on to the next feature. I think this is going to be of high interest to a lot of people on the call and will listen to this video. So that's highly available GPUs and stretch clustering. So what does this kind of mean? Well, you can fail over a virtual machine with a GPU between sites in a stretch cluster. This requires a shutdown and a move of a VM or a drain, suspend and drain, a suspend of the cluster node and a drain of the virtual machines, and then it will shut down the VM and move it over to the cluster. But it will not support live migration of a VM. This will be coming in a future release of Azure Stack HCI called GPU-P, which is GPU partitioning, or MIG, multi-instance GPU. Now, I've included a link in the presentation of how to configure GPUs for cluster VMs on the slide prior to this. Now, for a stretch cluster, though, let's discuss some further details. Firstly, you need to ensure symmetrical GPU models exist across the stretch cluster nodes in both sites. You need to create a GPU pool for each GPU model type on the cluster node that these GPUs are physically installed on, and then assign each model of GPU type to its specific GPU pool, as you cannot mix different GPUs in the same GPU pool. Finally, you would then assign the VM to the respective pool to match GPU required. That's a big mouthful. There's a lot of data to take in, and And first reading it doesn't make much sense. So let's try and explain that in a better way. So for example, if you had a 4-node stretch cluster with 2 GPUs, say they're the same model, this means there's one cluster node in each site would have a GPU. Now on that cluster node in each site that has a GPU, you would create a GPU pool with the same name, because you want that GPU pool to be the same name on both sites, and they both have a GPU each. Okay, then you would assign a GPU to that pool on either site. Then on the primary site where the workload is running, you would assign that VM to the GPU pool. The VM then that's running can now see that GPU. You would then have to ensure that the GPU driver is installed in the OS, whether it's Linux or Windows, and to change the shutdown behavior of that VM to support high availability failover. This is an active passive example. So if you now want to move to an active solution, you would follow the same theme, but increase your GPUs to 4. So that could be in a 4-node stretch cluster, that's 1 GPU per node across the 2 sites. And you would then create a GPU pool, and you would then assign a VM to one pool on one site and a VM to another pool in the second site. And you would have 2 GPUs free on each site. So 1 GPU in each site, 2 GPUs free, to allow those VMs to have failover as an active service. So providing an active service, but also support failover and also failback. So really the kind of best practices here is to assign 1 GPU for each GPU pool, but to also ensure a GPU is free in case there is a failover in the cluster or failover to the site in terms of a stretch cluster. Now, hopefully that makes a bit of sense, but this is why it's important, I think, to highlight that we offer a demonstration and a walkthrough through this end-to-end process, because there's quite a few moving parts here. But I think everyone would agree there's a high benefit here for machine learning, AI, for VDI, and obviously right now this is a DDA, direct discrete assignment, which is a VM to GPU direct assignment, the whole GPU. Obviously, as we move forward, we'll be able to splice those GPUs and VMs up even further. So let's talk about what's not supported on stretch clustering. So software-defined networking and stretch clusters are not currently supported today. That's something that's I'm sure is being worked on. It's going to come in the future, but it's not available today. And for Azure Kubernetes services for HCI, yes, you can install that and you can get that up and running, but will it work in terms of best practice? Will your deployment implementation work in terms of failover and failback with a stretch cluster? So Microsoft are looking at the implementation, the best practices, and spending some time there to come up with reference architectures to cover all of those areas. So once Microsoft have done that, then AKS HCI will then be supported. So in terms of best practice for stretch clustering, we're going to be covering storage, networking, and cluster configuration. Now let's jump into the storage area first. This is I think one of the most important areas just before networking. Now in terms of stretch clustering, it's always best to keep it simple. And the most simplest storage configuration in Spaces Direct is a single tier configuration, whether it's all NVMe or all SSD. This requires no device cache. It's actually the fastest storage option there. And it actually saves 4 GB of memory per terabyte of device cache if you had 2 tiers, providing more memory for workloads. And when combined with Storage Replica and Storage Replica logs, reduces write amplification and latencies of the overall system. So it's a very good place to be. So it's very fast. You've got a lot of performance throughput, a lot of IOPS in a single tier system. Now, with PCI-free architectures, you can scale to 8 NVMe per node and 24 SSDs per node. But now, as we're going into Gen 4 PCI-4 architectures, you can now scale to 24 NVMe per node. Now, an NVMe drive supports a queue depth of over 5,000, and a SAS SSD a queue depth of 256, driving overall higher throughput through that cluster node and through the whole cluster. Now, when you bring this all together, single tier plus more spindles, the more throughput you can put through on a drive across each cluster node, increases that throughput and performance. Now, the combination of these aspects, plus CPU, memory, and networking, will drive higher throughput and IOPS, because you have to get those areas right as well, and I'll go through those after this area. Now, when you combine with stored replica and intersite networking, this will obviously slow things down due to network latencies and bandwidth to keep the cluster in sync for data churn, leaving the remainder for workload performance. This is why it's important to leverage tested, validated configurations for stretch clustering to ensure all of these bases are covered, so you get the right networking, you get the right CPU and memory and storage configurations. So you're in the best start place, if you like, for all these areas. Now let's now jump into the network configuration. Now this is another important area of design. Now when you're considering the speed of your east-west network in terms of spaces direct within a site, let's call this intra-site, and live migration stored replica between sites, let's call this intersite. With a standard HCI cluster and single tier or flash storage, we may consider 100 gig RDMA, especially if it's all NVMe and PCI-4. For your east-west traffic for intra-site communications. Now, when you look at a stretch cluster, we will likely not have 100 gig networks available for intersite communication, unless this is dark fiber on a university or a major corporate. And there are exceptions these are exceptions rather than the typical. Now, if we consider that we will likely encounter 10 gig bandwidth or less for many customers, this could also be shared interconnect, requiring quality of service to ensure we have access to a certain percentage of bandwidth. Then we have, multiple 25 adapters would likely suffice for stored replica line migration, and also space direct, considering all the right performance has to go through stored replica. Now, we would also assign stored replica to specific adapters through network constraints to guarantee this traffic does not impede other traffic types. The same for live migration. We would assign to specific network and adapters and addresses, separating this traffic also. The final points are typical best practices to ensure jumbo packets are the same across all type of rack and spine switches. And one key area to kind of keep in mind, RDMA is not supported for inside traffic, and that's aimed at stored replica and live migration. And the idea is from a Microsoft kind of support and to keep things very simple and easy is to remove complexities here. So if you do decide to enable RDMA and you have networking issues, Microsoft will ask you to disable RDMA on an Azure Stack HCI stretch cluster. Now, RDMA is supported for intra-site traffic only, so your local S2D traffic. In terms of live migration, best to leave this as default for TCP compression, as there's no RDMA. So don't set to SMB, just leave as TCP compression. There's no RDMA in place. Now to cluster configuration. We recommend setting a preferred site at the cluster level for all active passive configurations to ensure this site is home for all volumes and VMs when the cluster is first started, or if network issues have occurred, disconnecting the two sites. As RDMA is not supported for intersite traffic, then consider the increase in CPU this will require and add more headroom in your design. That said, if you're modernizing your server platform after 5 or so years, then you'll obtain a 2 to 3 increase in processor scale anyways through the new modern Ice Lake and Milan processor architectures. Now, another area is we do not recommend to enable BitLocker or deduplication with stretched clusters at this time, due to the additional overheads this brings and the impact to workloads. Now to expanding and converting existing clusters. This is another interesting area. First of all, we need to ensure that all servers to be added are close to the existing configuration as possible in terms of memory, storage, networking, and processor pools. And everything needs to be symmetrical. The same amount of disks in every node in the cluster, the same amount of networking in the same slots. Very similar processor and cores and memory. So you are able to expand an existing cluster node and storage in a stretch cluster by first adding these to the cluster fault domain of site before adding these to the cluster. So what does that really mean? In this slide here, you'll see there's a link to the complete steps of how you would prepare and add new cluster nodes to an existing stretch cluster. But in essence, you would edit the existing cluster fault domain XML file. You would add the two new servers, one for each site, and then you would apply that configuration to the cluster fault domain. And then you would simply just add those servers to the cluster. The cluster would pick up those servers, recognize they exist in each site, and they would add the relevant nodes to each site and the relevant disks to the site scope pool in each site, increasing the processor capacity and the storage capacity of the overall cluster between two sites. Now, because this is all automatic, this takes away a lot of pain, but there needs to be these preparatory steps to ensure that that this all works. You just can't add cluster nodes to an existing cluster and expect it to work because it hasn't recognized what site it belongs to. And it's more of a horse before cart situation. You need to make sure the cluster knows about the node first, it knows about what site it belongs to, and then you can add the nodes to the cluster. Now, if we look at converting an existing cluster, now you may have bought an Azure Stack HCI 20H2, 21H2 cluster, and initially you've got that in a rack in your data center, and you may decide to look, I want higher availability. I want to now convert my existing cluster to a stretch cluster. You can do this also. For example, a 4-node HCI cluster can provide, N+2 resiliency. In comparison, a 4-node stretch cluster can provide N4 resiliency, doubling the fault domains and providing higher uptime. Remember, we talked about initially, beginning of this presentation around high availability. Well, you can use stretch clustering for high availability, and literally without requiring for disaster recovery. Wait, let me just get there. So when you're thinking about converting a standalone cluster to a stretch cluster, you can convert an existing 2 to 8 node HCI cluster to a stretch cluster without recreating the cluster and storage. And that's the important thing here. You would follow the similar kind of simple steps as you would do to expand an existing stretch cluster, except that you need to keep these things in mind. You may have noticed that I only mentioned a 2 to 8 node cluster and not larger to expand or extend an existing HCI cluster to a stretch cluster. This is because a stretch cluster supports up to 16 nodes. And so the existing cluster can be no larger than the 8 nodes to provide automatic conversion to a stretch cluster, because you literally have to add another 8 nodes, giving you the total of 60 nodes in each site. So if your existing cluster is between 2 to 8 nodes, then yes, you can convert that standard HCI cluster to a stretch cluster. And let's move on to additional use cases. Now, stretch clusters can have virtual sites and physical sites. Now, when we think about a stretch cluster, we typically think about physical locations. And we think about, the WAN links, the latency, the bandwidth, all of those things. But when we're thinking about, a virtual site, well, the proximity of the cluster is in the local data center. It could be in a single rack or an adjacent rack. So you could actually think about leveraging stretch clustering from the outset. Now, you will require twice as much storage, obviously, if it's an active-active solution. But if it's an active-passive solution, to look at the workloads, the storage requirements, and design that to fit whatever the SLAs, the availability that you want to get out of this. But if it's an active-active solution, then also to design the processor memory and storage to fit that requirement also. But the point here is that you can create a stretch cluster within a rack and have that higher availability, moving from 2 fault domains to 4 fault domains for the same 4 nodes in a cluster, and having to, yes, increase storage and maybe increase memory if and process perhaps is an active-active configuration, but not if it's an active-passive. But now you can start thinking about, the wider use of stretch clustering and into a lot more use cases. And at Acuutech, we talk with a lot of customers, and we recommend that stretch clustering should be a consideration, from the outset in a lot of the solutions, because your higher availability is there from day one. But that said, as I mentioned earlier, you can take a normal HCI cluster and extend it out to be stretch clustering. So if you've already run away and you've already got a HCI cluster in place based on Azure Stack HCI, then that is also something that you can come back on. So I will close off my session of the presentation today, and I will hand over to Tony to go over the scope sys sizing aspects for stretch clustering. Tony, over to you.
Thank you, Terry. That was an excellent presentation. Thank you. So I've got a lot to live up to. So hopefully I can follow on. So as Terry said, I'm going to do a scope sys demo. Our scope sys is Acuutech sizing tool. So this is how we size all Azure Stack HCI platforms, whether it's a single site, multi-site, whether it's stretch cluster, replicated cluster, it can do multiple different things. To do a full demo on this literally can take an hour. It's amazing the capabilities that are built into the platform. But today it's a very cut down version focusing purely on stretch cluster. So on my screen is the Acuutech Management Information System. I have a new customer called New Demo, and I already have done a bit of a Blue Peter, and I've got site 1 and site 2. So again, these are just logical sites, but think of these as single clusters in a normal environment, or we can join them together and make it a stretch cluster. So I'm going to site 1, and here in the middle is where I input information, and on the right hand side, it automatically updates and outputs information. So this tool's got amazing automation built into it, and it uses a repository for preset bombs and preset node definitions that it will try and pick and choose to give you the most cost-effective and correct solution. And as I put information in here, you'll see on the right-hand side, things update and different things happen. So this represents a 2-node to a 16-node cluster. So as Terry said, when we're doing a stretch cluster, we know we can't go above 8 nodes because it's going to be 8 nodes per site. But again, we use this for single sites as well. So I could be designing a solution and I need 200 terabytes of usable storage. So straight away, the tool updates on the right-hand side, and it's saying I need Chicago. All these names, Chicago, Copenhagen, are just logical names for the bill of materials. Chicago, it says 13 nodes, Copenhagen 9 nodes, but I only need 7 nodes of Rio. So Rio itself tells me the peak IOPS, it tells me the day working set, tells me the usable storage. So this is saying, based on my 200 terabytes of usable storage, I'm going to get 224 usable terabytes on the platform. which could be fantastic. That's a really great fit based on that basic information. Rio itself is based on a hybrid node. It tells me the CPU that's part of it. And if I look at the full BOM code, it tells me it's got dual 24 core CPUs. It's got 768 gig of RAM. It's got 72 terabytes of raw storage for each of the nodes. So I can get some really simple information that's straight out the box. The tool also critically tells me what I can't use. So there's two platforms here, which are both grayed out. So it says I cannot use these. So I can't pick a solution which cannot meet those simple requirements. So those solutions will not scale to meet this need. And sometimes that's really simple and that's really it. And sometimes we only need to put that. But now I'm going to put in a virtual workload. So I'm sitting down with my customer. My customer says I have 16 of the VMs. I've already pre-named them demo VM. Each of those virtual machines has 16 cores. So these are big virtual machines. They've got 64 gig of RAM. They've got 100 gig of daily writes for the daily working set and 4,000 peak IOPS. So they're quite big and chunky, and they are going to run on the solution over subscription of physical to virtual cores at 2:1. And this is really cool because I can put different workloads in at different oversubscription rates to do exactly what I want the tool to set. So I can be very granular in the information I put into this. So I'm going to put 60 virtual machines into there. So I've got my virtual workloads running, and now I can see I've got red lines and blue lines. And the red line and blue line represents the red is the CPU cores that are being consumed on the platform, and blue is the RAM. So this is a logical layout. This is not what it's going to do in the real world. And it always tries to populate the fewest number of nodes. It always goes from the first node right way up. So I know this node's blank. But in the real world, that's a really good thing, because this is telling me for my 200 terabytes of storage and my 60 VMs, I can support them on 7 nodes, and I can lose this entire node. That ensures I've got resiliency locally to the cluster itself. And I can prove that by going to here and selecting I want one resilient node. I can turn around and say I want more resilient nodes if I want, and it will start populating more nodes itself. So very quick and easy to build and confirm high availability locally within the cluster. So I'm going to set it back to 0 because I've already got them anyway, so that's fine. So it's great. This platform meets the customer requirement really, really well, and that's perfectly fine. So now that's my site 1 done. So now I want to replicate this in a production to DR scenario, active, passive, and I can do it very, very easily. So I can click on this tool here, replication of failover. I can choose the failover destination, and I'm going to say site 2. And straight away, this tool does some really clever calculations. So as we said, when you're replicating and stretch cluster or replicating cluster between 2 sites or more sites, the amount of churn, the amount of daily working set, change and new data that has to be processed on the local platform, but also sent between the 2 platforms is really critical. And we have specific NICs and specific bill of materials that allows us to do this, to split that traffic out to ensure we get best performance. And if you look here now, I now have storage replication NIC. So this platform within that BOM has put the correct NICs in to allow me to do that capability. So already it's got the intelligence built into it that once I get the BOM, it's a true BOM. I have the full BOM for the BOMs and the nodes, and I have the full capabilities for the switches. So this represents 2 100 gig switches, NVIDIA or others, and it's got the correct BOM built in for them as well. So it's not just that, it has the cross connects for the 2 switches to make them a highly available pair, etc., etc. So if I go into my site 2 now, site 2, I have no local workloads running. I have no local virtual machines running, but already I have it's grayed out. It may not show too well on the screen, but now this is showing me the replicated workloads from site 1. So they're not running here. This is what they would look like if they were running. So I can easily see how many nodes and what platforms I want. And there's no local storage being consumed, but I can see my replicated stores here as well. And it's not just the replicated store for this workload, it also calculates the back end for the logs and the history files, etc. you need to have as part of Stretch Cluster. So this is great. And what the other clever thing I can do, I could turn around at this point, if I was doing a replicated cluster, I can say, well, my site 1, when I replicate site 2, I want to consume half the resources. I want my tier 1 workload. So out of those 60 VMs, 20 of them are my tier 1. I want them to work as normal, and I want to consume half the resources for the other virtual machines, and I can do that very easily as well. So it's excellent what we can do, and we can obviously save on cost and hardware from that point. But typically, people are moving to active-active. So active-active is definitely becoming much more popular. So at this point now, I'm going to take my 200 terabytes and my 60 VMs, and I'm going to distribute them 50-50 between the two sites. So here now, I'm going to say I want 100 terabytes of usable storage, and I'm going to say I want 30 VMs that I'm running here, and I'm going to say I want to replicate back to site 1. So now I'm going to do bi-directional full active-active failover between the two sites. And if I go back to my site 1 now, and if I change these figures to represent that, now I've got my 100 terabytes and I have my 30 VMs. So now it's still showing me I still need seven RIO of the actual node platform itself. So I still need 7 in each site. So this is now a 14 node stretch cluster. But the storage, etc., that I was already using is still exactly the same. So it hasn't changed, and I had enough capabilities built into that platform that I didn't need any extra nodes. And if you can see here now, these bold or fixed red and blue lines, that represents the local resources being used. And this represents the faded lines, represents the scenario of a full site failure. So this is what would happen. These VMs are here. They are ready as a hot standby. And if I was to recover, if site 2 failed, because I'm in site 1, that means I can easily recover all my virtual workloads and all my data. And I've got enough capacity and capability on this single platform, now as it'd be a single cluster, to actually recover fully and still stay fully operational. And I've still got local high availability as well. So it is very, very simple for me to do a stretch cluster. And if I just prove that, I go back to site 2. Site 2 is going to show the same capabilities. So now I can see again, I've got my 100 terabytes and my 30 VMs running locally here, and all these pieces of information are faded out. I have my replicated store. I have my own local storage being consumed. And just going on a little bit from this, the daily working set is the biggest thing you have to calculate in the real world. So the daily working set, the churn and the change data is so critical to understand and to make sure this happens and works correctly. And we have to think above just the Azure Stack HCI cluster. So I've got to think now I'm going northbound by my site 1 and site 2, whether they're 2 physical sites or 2 logical entities. They go northbound into a customer LAN, that then goes off into some sort of connectivity between the 2 sites. And you have to make sure you configure those elements correctly, as well as the northbound connections, to ensure that all this works seamlessly. So it's great I've got these separate NICs. It's great I know the platform itself knows how it's going to configure itself, but there's still other things you have to do on the customer LAN and things beyond just Azure Stack HCI to ensure this operates correctly. So that's my quick demo. Hopefully that works for everyone and it makes total sense. It's an extremely powerful tool. I can also use this actually to do multiple replicated sites. So if you think of, so this customer, if they have 100 sites and they've got 98 sites that are remote, which I can build with 2 node or 3 node clusters, I can replicate all those back into the central data center. So I can have 2 sites for my production and DR or active workload running locally, and I can replicate all those back there. It's not stretch cluster, this is replicated cluster using the inbuilt tools. But again, it's very powerful and I can understand the requirements and size of these platforms very, very simply. And we do this for quite a lot of different customers from a robo point of view to quickly and easily show them how much data is going to be consumed, how much. And these are real world figures that you're going to get on the platform when it's deployed. So just moving on from that, I am going to now go through a couple of slides. So from the Acuutech point of view, this is our deployment process. So we can help solutions and customers from the very start right the way through to the very end, plus post-deployment activities as well. So from a pre-sales point of view and from a sales point of view, we make the solution design and scoping much simpler. ScopeSys itself is the tool that I just showed you. From that, I can take an output. That output includes the bill of materials, it includes all the sizing and information I've done. I can easily send that to my colleague and get it peer reviewed. I can easily send this straight off to obtain pricing. And within that as well, we have turnkey solution packages. So we know the platform itself we can support stretch cluster, we can support migration services, we can do a number of different things that can get included at the same time to ensure that this platform is built and deployed correctly for the customer to meet their expectations from the very start. And then we also had the advanced design as well. So we can do network assessments. So again, the stretch clustering above and beyond and outside the Azure Stack piece is very, very important. So we can do an assessment on the existing customer LAN. We can look at the capabilities and the throughput from the links between the two sites. And it all just ties up to ensure that the end-to-end solution delivers what it is supposed to on the tin, and it does exactly what it's meant to for the customer. From that point, we then have a standard process to do that, and that then feeds into our onboarding process. And the onboarding process is a standard process and documentation we use to onboard every single Azure Stack HCI customer, whether it's a single cluster, multi-cluster, stretch cluster, and everything else in between. And it covers two things. It covers the deployment planning and the actual deployment itself. So the deployment planning is captured using some standard operating procedures, using some standard templated documents. Very, very simple, very, very easy to fill in with a single customer. You don't need to go to the networking specialist and the storage specialist, etc. Very, very quick and easy from a single workflow, capture some very basic information to allow us to build these platforms. Then we have the full deployment planning. So that then feeds into a wizard and how we build the automated platform itself, as well as capturing key bits of information which are often missed, such as how do I get into the actual physical site? How do I get into the physical data center and build rooms, the location of the racks, and some simple information that are simple gotchas, but it's key you capture all these key bits of information to make sure the process is seamless end to end. And we removed as much of the human element from this as possible to make it much quicker and easier. And we don't need a lot of time from the customer, and we know we can do the same thing over and over again. And then deployment itself. So we do deployments automatically. So we have automation built into this process, which allows us to do end-to-end deployments just from putting a USB stick into and just starting and booting the platform from script builds. Or alternatively, we can go through a manual build process. Sometimes we work with the customer and the partners to do this as well. But automating removes, again, the human element. So if I give a script to 10 different people, 10 different people will follow that script in 10 different ways. And there's always a little bit of information, or they put a capital letter in, or they just do what they've done last time, and the process is different. So we want to remove that and do as much automation as possible. And we have our full professional services to do that piece, as well as do the stretch cluster, as well as doing any services. So if you want to bring things down or do backup the service or deal with the service going out, or bring down AKS onto the various platforms, etc. And then we can do migration services. So now we have these two platforms sitting side by side and connected. We need to be able to migrate from A to B. And we all know migrations are very, very difficult. So we have a specific process and suite of tool sets that we use as part of a migration services. So it's not just for data and VMs. There is some user services as well as around if you're going to start tying in things like Office 365 and some other platforms as well. And we have all these that are all validated in processes we use time and time again for all of our customers. And then we have the value-add services on top. So again, we have hybrid and cloud services. So there's loads of services from the hybrid world, from bringing cloud solutions on-premise, Azure Stack HCI, as well as obviously going from on-premise out to the cloud. We have all these turnkey services that are just quick, easy, validated, tested. We can just deploy them very, very easy on top of the physical platform. And then post-deployment, we have the full support service, the full lifecycle management of the platform, and everything to be a valued partner and a value advisor to that end customer as well. So my last piece, hopefully everyone is aware of this. So Microsoft Ignite, hopefully everyone's been in and built up their slides and their attendance and what different sessions they're going to attend. We're going to leave this on the screen for a while because there's a lot on it, but this focuses on all the Azure Stack HCI announcements and sessions and different things that are happening during Ignite. There's hyperlinks built into this as well. So from the end of play tomorrow, this video will be up on the Acuutech video website, and you'll be able to go into this and actually access or see these hyperlinks. We're going to share these hyperlinks as well via social media, so it's much easier for you guys to go in. But it's very simple to go into Ignite, very simple to do Azure and search the different sessions. But the announcements, critical announcements on the left-hand side, are the ones you really do not want to miss. Some really great sessions are built to be done as well, and there's lots of sessions. There's loads of information you can grab from that. So at that point, Terry, that's me done. I'm going to hand back to you for Q&A.
Hi, yes, great. Yeah, so I've got some questions that have come in here, which I can pose to Terry, if he wouldn't mind answering them, and we go through those. So Terry, the first question I've got is, how many nodes can you lose from a multi-site stretch cluster?
So 4. 4 is the maximum that you can lose. Considering that if you have, a 2 node on one side and a 2 node on the other, and you had nested mirror or nested map volumes, you can support n+2 on a 2 node on a side. And if you have those spread across as a 4 node stretch across 2 sites, then you can support n+4. Then as you go from a 4 node upwards, that naturally supports n+2 per site, and you then double that across 2 sites for a stretch cluster, again n+4. So n+4 is the maximum.
Perfect. Next question is, can you use switchless for stretch clusters?
You can, within various configurations. So a 2 node on each site can support switchless for the Spaces Direct network, but obviously for the live migration and the storage replica network, you can't. You require top of rack switches because they have to connect into the spine switches and then replicate between the 2 sites. So you can for the storage replica, for the Spaces Direct network, and typically for a 2, 3, and 4 node cluster per site configurations only.
Cool. Next question is, can you use SDN, so storage defined networking, for a stretch cluster?
No, you can't today. No, that's not supported today, but I'm sure that's coming in the future.
Yeah, okay, so watch this space and we'll let people know when it is. The next question is, thin provisioning supported?
It is supported in a stretch cluster as well as a single cluster, standard cluster configuration. There are some rules around that. So thin provisioning abides by the rules of RFS up to 64 terabytes, so don't create volumes larger than that. Windows Admin Center won't allow you to create volumes larger than 64 terabytes, and it'll provide guidance. But obviously I mention this because in PowerShell you can create volumes of all sizes. So please follow those best practices. But yes, thin provision is supported in stretch clustering.
That's good news. Next one is a little bit more of a technical worded one, but I think you may have actually covered it with the first question. But the question from one of the users is, with a stretch cluster of 4 nodes per site, in total 8 nodes, can I tolerate the failure of one site and 2 nodes in the second site? I think
yes, you can.
Your n plus, yeah.
Yes, you can.
Good. Just moving down on the questions. With a stretch cluster, is it mandatory to use level or layer 3 routing between sites, or can we use layer 2 switching?
No, it's layer,
same location. Yeah.
It's layer 3 switching is between subnets between 2 sites is the required network configuration.
Just a couple more questions to go. Is a one site AS HCI cluster, sorry, in a one site HCI cluster, can I tolerate the failure of more than 2 nodes?
It will switch over to the second site if you have a third failure in a site. So if you have a stretch cluster across 2 sites and you had more than 2 failures in one site, that site would then go offline, and those services, volumes, the disk reservation and the volumes and the VMs will switch over to the secondary site. So no, you can't suffer more. You can't survive more than 2 failures in one site.
And the last question, which I think was semi-answered with the second question, it was around using switchless topology in a stretched cluster configuration, which I think we can do. It was regarding the maximum nodes that can be used. Is it 2, 3, or 4? Yes,
2, 3, and 4, and that's typically for a standard cluster as well. But then it's how many PCI slots do you have free? Are these dual or quad adapters? So it really is the chassis that's chosen in the design and the amount of free PCI slots, and then the type of adapter that you use for this to allow whether that's a 2 node, 3 node, and 4 node. Typically a 2 node, 3 node is kind of the area that most customers land in, the 4 node. With stretch, you're going to run out of PCI slots.
Great. So that obviously, again, it's unfortunately it's been posted as an anonymous user, but if anyone wants to come back with that question, we're more than happy to look and discuss it further with them. And that, Terry, concludes all the questions that have been posed.
Wonderful. So if there's no further questions, let's please bring this to a close.